Okay, today I want all of you to sit with paper and pen. Okay, sit with a copy and pen. We'll do sums today. Okay, all of you bring your copy and pen. All of you carry copy and pen. Okay, from today we'll start sums. So for the coming 2 weeks or so, 2 weeks or 3 weeks, all of you carry copy and pen. Okay, once you are ready, tell me. Yes, are you all ready with paper and pen? Ready? Shall I start? Yes, are you ready? Tell me.
Yes, ma'am.
Okay. Rest? No one speaks. Why is it so? You don't have microphone? Huh? Please unmute and tell. Are you ready with your paper and pen?
Yes, ma'am.
Okay. Okay, now see, today we'll start with large sample test. Okay, probably you have done these tests in last semester. If not, I'm again teaching you. Okay, so large sample tests are see, sampling theory I have not taught you yet. So I'll just give you a brief about what is samples. Okay, sample is a set of respondents basically, from whom you will collect the data. Okay, sample means this is a set of respondents or set of people, set of subject from whom you will collect the data. Okay, now samples can be of any size according to your convenience, and there are some rules also. I'll teach you after this numerical portion. So following that rule, you select the sample size. Okay, what is it going to be? Is it 10, 20, 30, 40, 50, 100? How much? It depends on your what to say, on your comfort zone, on your abilities, on your following the rule. It depends. Okay, so suppose you are selecting a sample of more than 30. If your sample size is more than 30, then you can apply this large sample test. Any sample which is more than 30 is called a large sample. Okay, and any sample which is less or equals to 30, less or equals to 30, they are called small samples. Okay, so today we are starting with a large sample. That means the samples whose size is more than 30. Okay. So now there are different types of tests. Okay. Z test also you can apply for different types of situation. So first thing that you will write in your copy, first heading you will write large sample test. First heading you will write large sample test. See, I will assume that you are writing. Okay, so I will go slow. If you're not writing, it's your loss. Okay, because I cannot see you. And from tomorrow, please make sure your cameras are on so that I can see you, who is writing and who is not writing. I'll also keep my camera on. You will also keep your camera on. Okay, from tomorrow, so that I can see who is writing and who is not writing. Okay, now I'll go by assuming that you all of you are writing. So at the heading you will write large sample test, and in bracket you can write sample size more than 30. Like that you write sample size more than 30, so that you remember that which test will be conducted for what size of the sample. Bikram, sit with a copy and pen. All of you sit with a copy and a pen. Okay, so you will write large sample test, in bracket you will write sample size more than 30. Okay. Under that you write number 1. You write number 1. Test for a specified proportion. Number 1 you write test for a specified proportion. Test for a specified proportion. Test for a specified proportion. Underline it. Underline it, and after that you write the last line in this small paragraph. This line, it is required to test the hypothesis that the proportion P in the population has a specified value P naught. Write this line. After writing test for a specified proportion, underline it, and under this you write this line. It is required to test the hypothesis. Like that you write. It is required. It is required to test the hypothesis that the proportion that the proportion capital P in the population Yogesh, sit with a copy and pen.
Ma'am, I'll take from my friends. I'm out actually.
Then why you are attending class? Today I'll do sums. Leave the class then.
I'm in my shop actually in the morning.
Okay, right now. It is required to test the hypothesis that the proportion capital P in the population has a specified value P naught. So proportion P will be a value of the population. Okay, population means from the entire area which you have selected for your study, that is called the population. Okay, so it's not that you will collect data from each and every sample in the entire population, but you will select some sort of sample. There are ways to select sample also. I'll come to that after numerical portion. So you need to select a particular sample. Say out of the area you have selected of Siliguri, the households of Siliguri. Say for example your area is households of Siliguri. Then the entire households is the population, and from that population you need to select a particular sample. And that sample size depends on some calculations, and the way to select the sample also depend on certain rules. Okay, so from that entire population, suppose you have selected a sample, then this line, no, it is required to test the hypothesis that the proportion P in the population, so that means this capital P will be a value of the population, and the H naught, that is the null hypothesis, will be to check whether this proportion P, that is capital P in the population, has a specific value, that is P naught. Okay, this is the first type of test that you are learning, which is called test for a specified proportion. For a specified proportion, you will apply this test when a particular value you can take of a population. About the population, certain specific value will be provided to you. Okay, say for example the mean income of the households of Siliguri per month is 30,000. Say for example, So this specific value will be given to you, and accordingly you will proceed. Okay. Now, if the sample size n is the sample size. Okay. If the sample size n is large, we use the test statistic. You write like this. If the sample size n, that is small n, is large, if the sample size, that is small n, is large, we use the test statistic. We use the test statistic if the sample size n, that is small n, is large, comma, we use the test statistic. We use the test statistic. Now write this formula. This is the first formula, okay? This is the first formula. Write down small z. Z equals to, you can see the formula, right, on your screen? See and write. Z equals to, in the numerator you will write small p minus p naught, small p minus p naught divided by SE of p. SE means standard error, okay? SE means standard error. SE of p, small p. So what you wrote? Z equals to, in the numerator, small p minus p naught, capital P naught, which is a specific value of the population, and in the denominator you will write SE of p, that is standard error of p, small p. Okay, small p. Now this small p is an attribute. Okay, write down where small p is an attribute. That means this will be an information about the population which will be given in the question. Okay, right. Small p is an attribute. Write down small p is an attribute. And standard error of p, SE of p, SE of p equals to, SE of p is equals to, write down this formula. You can see on your screen, right? Where SE of p equals to root over PQ by N. PQ in the numerator and N in the denominator. Where SE of p equals to root over PQ by N. Don't write if H naught is rejected, okay? Write root over PQ by N. Written? Please tell me, have you written? Done till this much? Tell me.
Yes, ma'am.
Yes, ma'am.
Okay. Okay. Now see, don't write this part. Just listen to me. Huh? Try to understand. Critical region, you remember? 5%, 1%. Critical limit or critical region, like that we can say. You remember in the last class itself I taught you this one on Thursday. That there are 7 steps of hypothesis, and this is probably the 4th step, where you need to select the critical region or critical level. Okay, if it is 5% given in the question, so 5%. If it is 1% given in the question, then 1%. If nothing is given, then normally we go with 5%. Okay, so these values you need to remember. Okay, for a proportion test for proportion, you have to remember these values. See, Z greater or equals to 1.96. This Z will be the value which you will calculate using the formula which I gave you right now. Okay, Now, if this calculated value of z is greater or equals to 1.96, then we reject the null hypothesis. These all values are for rejection of null hypothesis. Okay, and at 1%, if the value of z is greater or equals to 2.58, then we reject the null hypothesis. Now, this p greater or equal, greater than, less than, these two option. Okay, first let us do this problem. One problem we will do based on this first condition today. That is when at 5% level, p is not equals to p naught. What is this? P is not equals to, let us do a sum, it will be clearer. Okay, write down this problem please in your copy. I don't think so you have books related to statistic. If you have books, try to follow the statistical methods by N.G. Das. Okay, try to follow statistical methods by N.G. Das. Volume 1 and 2. Volume 1 is available in the market, volume 2 is available in the market, and volume 1 and 2 together it is available. Try to follow that book. These problems are from that book only. So write down this problem please. Example 14.20. A dice was thrown 400 times. A dice was thrown 400 times. What is a dice? Anyone? What is a dice?
Ma'am, a dice is a shape which has 6 sides.
Yes.
Yeah, it
That
has
is
6
a dice.
sides. Yeah.
We play
Ludo,
we use
right?
this dice. Yeah, we play Ludo with this. Okay. So that dice was thrown 400 times. Okay. And 6 in inverted comma you write, single inverted comma, 6. That is a number 6. Resulted 80 times. A dice was thrown 400 times and 6 resulted 80 times. Okay, this is a given information. From here we will calculate the value of small p. Okay. A dice was thrown 400 times and 6 resulted 80 times. Full stop. Do the data justify the hypothesis of an unbiased dice? Do the data justify the hypothesis of an unbiased dice? Unbiased dice means the dice doesn't have any defect. Okay, the dice is good. It's not giving you any default result. It is an unbiased dice. It's a normal dice, and normally 880 times has occurred 6. The number 6 has occurred 80 times out of 400 times thrown. Okay, now from this given information you will have to calculate, you will have to test whether the dice is an unbiased one or not. Okay, now for this you need to have some knowledge about probability theory. Probability theory had to be taught in your 5th semester. Okay, so those who have done the classes properly and have understood, they will only able to understand probability theory. So if a dice is thrown, the probability of occurrence of any number in the dice, be it 1, 2, 3, 4, 5, 6, 6 numbers are there, no, in a dice. So probability of occurrence of one number in the dice thrown is always 1 by 6. Okay, because there are 6 numbers and one number has got 1% chance of occurrence out of the 6 numbers. One number will occur once out of the 6 numbers. So we say that the probability of obtaining a 6 or whatever number which is given, 1, 2, 3, 4, 5, 6, anything, has got a probability of 1 by 6. So you write, let us assume that the dice is unbiased. So we have to go with the assumption that the dice is unbiased. Okay, write down, let us assume in the solution. Let us assume that the dice is unbiased. Let us assume that the dice is unbiased. So if it is unbiased, then the null hypothesis will be what? That is, you write, that is the null hypothesis. That is the null hypothesis is that is the null hypothesis is that the probability of obtaining a 6, the null hypothesis is that the probability of obtaining a 6 obtaining a 6 is 1 by 6 is 1 by 6. So since 6 numbers are there, no, so one number has got 1 by 6% chance of occurring. So this is a fact, okay? You have to remember. If you don't have proper knowledge about probability theory, then just memorize this fact, that if a dice is thrown, then any number on the dice has got a chance of occurring 1 by 6 times. Okay, now see, if you remember, the first step of hypothesis was what? Setting the null hypothesis in a way just the opposite of the assumption, right? But that theory is disgraded over here. Why? Because you have to write the null hypothesis in an equals to form always. Okay, in an equals to form. So since this problem is of a testing of a single proportion, that's why this null hypothesis theory, which I told you, that always select a null hypothesis, write null hypothesis in the way that it is just the reverse or the opposite of your assumption. So that will not be followed in this test of single proportion. Okay, because null hypothesis has to be written always in an equals to form. So you will write H naught, write this portion, H naught, in bracket you write small p equals to 1 by 6. Now we are sure that this null hypothesis is written in an equals to form. Okay, so you write H naught, in bracket you write small p equals to 1 by 6. This is our null hypothesis. Written this till this much. H naught, in bracket p equals to 1 by 6. Next you write alternatively the dice is not unbiased. So the opposite of null hypothesis will be your alternative hypothesis. So if null hypothesis is the dice is unbiased, that is the value of small p is 1 by 6, then what will be the alternative hypothesis? Write this line, alternatively the dice is not unbiased. So on alternative hypothesis we will assume that the dice is not unbiased, that is it is biased. Okay, so we'll assume that the dice is not unbiased. That is the alternative hypothesis. Write down, that is the alternative hypothesis H1 in bracket write p not equals to 1 by 6. P not equals to 1 by 6. Okay. So this is the condition of related to this first one. Look at this rejection rules for H naught, table 14.4. This is the first case. Okay, not equals to. We are not writing any greater than sign or less than sign. We are writing not equals to. This is called two-tail test. Okay, this is called two-tail test, where we are just mentioning not equals to. It can be either greater than or it can be also less than. Simply we are writing not equals to. Okay. Understood till this much? Tell me please. Understood till this much?
Yes, ma'am.
Okay. Okay. Rest of the portion we'll do it tomorrow. Okay. We'll have to go slow in the numerical portion. Now we will go slow, but make sure you're writing whatever I'm saying. Otherwise, you will not learn. Take my words, please learn how to do this test. Only then you will be able to apply this test in your research work. Okay. So please be present in these classes and sit with a copy and a pen. From tomorrow, all of you will switch on your camera and then sit. Okay, all of us, we will switch on our cameras and we'll sit, so that I can see who is writing proper. It's like a normal classroom. The environment will be like a normal classroom. Okay, so all of you sit properly tomorrow. I know now at this moment you might not be wearing proper formal dresses like that. That's why I told you not to switch on the camera today. So from tomorrow, make sure you all of you switch on the camera. Okay, wear proper uniform and switch on the camera. You know that these classes are getting recorded. Okay, so sit properly with your uniform. If you don't have access to your uniform, wear any formal shirt or dress and then sit tomorrow. Okay, at 7:40 a.m. so that I can see. In numerical classes, I will do like this only. In numerical classes, I follow this system only. So you will also follow this system from tomorrow. Okay, we will proceed tomorrow for the further solution of this problem. And then we will do sum of greater than and sum of less than also. Those will be one-tailed. Okay, tomorrow we'll do.
Ma'am,
Yes.
ma'am, what did we conclude from these 2 points?
Yeah,
Whatever we,
tell me again.
ma'am, what did we conclude from these 2 points that we had just written?
H0 and H1.
Yes, ma'am.
Now we will test. Now we will test with the help of this formula. No? Z, I have given you the formula. With the use of that formula, now we will test and see whether null hypothesis can be accepted or rejected. From that conclusion, we can, from that calculation, we will, today we have not completed this sum. That's why this question is occurring in your mind. But tomorrow, when we will conclude this sum, then your question will be clearer. Because see, this are the assumptions now we are making. Now we will apply the formula and see whether the null hypothesis can be accepted or rejected. And from there we can draw the conclusion. If it is accepted, then we will say that that the dice is unbiased. And if it is rejected, we will say that the dice is not unbiased. Okay? You have to wait till tomorrow. Otherwise, you will not understand it properly. Okay, now quickly give your attendance, okay, and then leave. See, every day when I'm joining the marketing class, those of you are in marketing, listen. Every day when I'm joining the marketing class, up to 12 minutes, 14 minutes, 1 or 2 people are joining, okay, and then I'm just ending the class because it's kind of a demotivation to take the class when only 1 or 2 people join. So if you are not attending the classes, those of you who have opted for marketing, to them I'm telling, if you're not attending classes, okay, no problem, but go through the Moodle classroom. Okay, in Moodle I am uploading materials related to advertising and sales promotion. Okay, please go through that Moodle work and go through the materials which I am uploading. Okay, and try to understand what is there and what is not, and then you can revert back to me. Every day it is kind of a demotivation to take class with 1 or 2 people, and you are all are matured. How long I will run after you? Tell me. You all should understand on your own. Na? You are not understanding, so what can I do? So what I'm doing is I'm just ending the class, but I'm uploading the materials in Moodle. Just have a look on that. Anyways, please respond. Ayush Pradhan,
Present, ma'am.
Abhishek, Ankita, Orgho, Ayush Charasia, Bikram,
Present, ma'am.
Deepa, Divesh, Diksha, Isha, Hemant,
Yes, ma'am.
Jasmeet, Landu, Pema, Pulamu, Pooja, Prajwal, Praraj, Prashant, Pratiksha,
Yes, ma'am.
Present, ma'am.
Prashant.
Yes, ma'am.
Okay. Prayas,
Present, ma'am.
Raj, Rajeshwari,
Present, ma'am.
Ronak, Rina, Ritik,
ma'am.
Sahil, Sejal, Sheetal,
Present, ma'am.
Shruti, Shubham, Sparsh, Srishti, Swikar,
Present, ma'am.
Valusha, Wangchu, Yogesh, Yongthen.
Yes,
ma'am.
ma'am.
Yongthen.
Yes, ma'am.
Okay. Yes, given. Okay, we'll finish this sum tomorrow, okay? And all of you, please be present. Those of you who are present today, at least you people be present tomorrow. Otherwise, you'll not be able to track. Okay, the attendance is taken. You can leave the class now.